Okay, well, it's 10 o'clock. We'll do our normal housekeeping stuff, and the last of the late arrivals will turn up. It's just like a normal classroom, isn't it? Where there's always a few people who are running late from the last class. So where will we start? Let's go to here. We'll get this set up. So our Pear Deck code for today. So you need to go to joinpd.com, and that's our code to get into today's lesson, which is OHMZU. Some orange highlighters, memorize, zesty umbrellas. So while you're doing that, I'll just sort of start a little bit of the housekeeping general stuff. So this is the Year 8 class. You don't have to be in Year 8 to be here. Generally people are. And so yeah, just make sure that this is the one that you wanted to be in, was Year 8. If you're wanting one of the others, we're all on at the same time. So that's a consideration. And today we're going to be doing a bit of a review of the first part of the Algebra chapter. So if you probably have done a little bit of algebra, whether you've done it this year or you did a little bit last year. So it's good to sort of have done a little bit or looked at the topic before you come to these, just so you're a little bit familiar. And then you can also ask specific questions that you sort of know already where you might be a bit stuck. So there's just a few who haven't made it in. I'll just repeat that again. So we do some interactives using this Pear Deck, and to access the Pear Deck you need to go to joinpd.com and our code OHMZU. There's a couple of people in there, a couple of people missing, but that's okay. Okay, so let's start the class for today. People can still join in as they come, and I know Miss J will help them out when they join. So yes, we're doing Year 8. This is our 4th lesson. So far we've been talking about basically types of numbers. We've been looking at real numbers. We did some fractions and decimals. We did some negatives and some integers. And then we did some percentages. And we also then last week did some ratios and rates. And today is our first foray into letterland, I suppose. Just the general housekeeping stuff. The important bits are that it is recorded, and you'll be able to access the class at that web address. So mathspace.co/au/academy, and all the previous recordings are there, as well as for other grades as well. So they're all on that page. The slides that I'm using today will be there as well. So you'll be able to access them to go back through in your own time and at your own speed. And now just with regards to the Zoom, so there's 2 types of ways you can talk. One is through the chat that we've been using. We do that general chat, the beginning and the end, just you can get a feel for that you're sort of, in a class amongst lots of people. But then throughout the session, if you have a specific question, you're best to throw that into the Q&A, and Miss J will be able to answer that first, and then we can wrap back and look back at the end, and I can have a look at what's left over. So during the middle of the lesson, you won't have access to the Zoom chat necessarily. So don't feel like anything's gone wrong or that you've been disconnected. It's just that we turn that off so that we can all sort of stay focused. So again, we'll do a little bit about who we are. So like I've said before, if we were in a classroom all together, we'd all be getting to know each other. I'm a bit of a storyteller, so you'd always be hearing lots of stories about me and my chickens and my garden. When I was teaching in a school a while back and my son was little, there was always crazy stories about soccer. But this week we're going to talk about puzzles. It turns out both Miss J and I love puzzles. So for me, I love sort of the more numbery type puzzles, like and sort of logic deduction puzzles, so Sudokus and Kukurus. I do like jigsaw puzzles. I tend to do those with my parents. My son hates jigsaw puzzles. But I do get a kick out of these puzzle memes that go around the internet. They sort of fly around through social media from time to time. My mum always sends them to me and says, "Here, what about this one?" And I'm like, "Yeah, what do you think? What do you think?" That's very teacher talk, isn't it? Why don't you answer that first? So that's sort of a bit about me. What about you, Miss J?
Yeah, I love puzzles as well. I tend to like word puzzles. I tend to do them more often. But now that we've been kind of in this remote working and remote school for my son, we broke out the jigsaw puzzles. You can see a picture there of, this is puzzle number 3, and the other 2 were 1,000 pieces as well. One of them we did in 3 days. I couldn't believe it, but we were addicted to it, which is really sweet because I used to do puzzles with my grandparents when they would watch us in the summertime. So it's been really nice to be able to break these back out and continue that tradition with my son.
Just as a side note on jigsaw puzzles, I used to have a big ply board that I had marked out where the edges of the normal puzzles were, and then you could just pick up that and take it to another room so that it didn't take over the dining table.
Yes, exactly. We had that same problem. So my partner went out and bought us that table that you can see so that we could have a specific puzzle table.
Yeah. So I'm interested in all of you guys. So what do you think about puzzles? How much do you like puzzles? So this is just an introduction to our interactives, basically, if you've not used them before. On your screen now, on your Pear Deck slide, you'll have a little star, and then you just drag that down to how much you like puzzles. Like you don't like them, you like them lots, or somewhere in the middle. So if you just throw your little stars down there. Oh, that was quick. People are getting in there. Put that up now. We'll get a bit of a feel. Here we go. Here are the stars going in. Fantastic. See if you can line up your stars. Now that you can see all the responses, see if you can move them over a bit so we make a bit of a graph. Just a couple of people at that lower end. That's okay. Not everyone has to like puzzles. My sister's not a fan of puzzles at all. Neither's my son, actually. He finds them frustrating. Yeah, it's fantastic. So yeah, a bit like us, Miss J there, they sort of like puzzles a fair bit. So that's sort of basically how the interactives work. There'll be a little pair at the bottom of the screen, and then there'll be something for you to do. It might be drag an icon like this one, or it might be to do some writing on the screen and solve a problem. So yeah, that's just our first one. Just locking your stars there. I'm going to lock the screens in 3, 2, 1. Fantastic. Okay, thanks everybody. That was good. Okay, have I missed any of the normal housekeeping, Miss J?
No, I don't think so. I will switch the chat over to where you can just chat to the panelists, and I'll also close down my video now so that we can focus on the lesson.
Thanks, Miss J. Okay, so just to connect in with what we've been doing, where are we? So this week we're doing the first couple of parts of algebra. So we're going to look at like algebraic terms, simplifying expressions. We're going to look at addition, subtraction, multiplication and division, and then some basic simplifying. And then next week we'll do part 2. So algebra was split up over 3 weeks. So next week was going to be about expanding and factorizing. And then the third piece of that is about substitution, and we'll also do another bit of a review of the other algebra stuff. So as always, we sort of target these lessons as a little bit of a review session. So it's sort of like a check-in. Do I know all the real important key points that I need to know about these specific subjects? If you want some more specific, tailored, specific lesson videos, then one option, if your teacher isn't doing videos for you, might be to do and log on and check out Eddie Wu's videos. So there's a website up there, top right corner, wootube.mathspace.co, and for each of the sections in our Mathspace book, there's a couple of videos that are there that cover the content in a more detailed way. So it's just like being in his classroom. So that's just another option. There are heaps of videos around, but those ones are sort of mapped already to our textbook. So that's sort of one easy way you can get some more detailed learning. So we're going to be looking mostly at our Mathspace textbook. I'll just show you what that looks like. Make this a little bit bigger. There we are. So here you can see we're in the Year 8 textbook. We've already done chapters 1 through 3. We're up to chapter 4 this week. And so there are those 5 sections. We're only going to look at the first 3 today. So that's what I said about the 4 operations: add, subtract, multiply and divide, and then simplifying stuff that's all mixed in together. So in our Mathspace textbook, now if you don't have access, you don't have to have it to watch this lesson. I'm just going to talk about the concepts generally and use some of the questions that are in this book. But if you like the look of it, or you want to be able to come back and do the questions, or do some of the stuff that I've shown you, you can get access. You just need to ask your teachers and they can get access for you for free. That would be fine. So each of our sections has a little bit of a lesson. I'm going to sort of talk a little bit about the stuff that's covered in these lessons, and that's sort of written all out there. At the bottom, we've got practice questions where you can see the solutions, or you could watch videos and see how a teacher would do this question in front of you. On the next page, there is a page of questions, and it covers all of the sections in that particular textbook. So it's just like most textbooks that you have. I expect if you're in Year 8, you've probably got a textbook at home. It may be a printed one, or you might have some sort of digital access to a book. All of those textbooks will have an algebra chapter. So like I said, you don't have to have this, but you're very welcome to get it, get your hands on it. And then you'll have a whole heap of questions like this that you're going to be able to do. And we'll do a few of those during the lesson today. Okay, we've talked about that. So that was one of the puzzles I put up there. And you might see these going around, and we did see that most of you in the room do like sort of puzzles, and I don't know if that's number puzzles or jigsaw puzzles, but certainly applying your brain to different things, I think, is what categorizes a puzzle. But this puzzle, actually, even though you may not use algebra to solve it, the type of thinking that's going on in your head is kind of what's happening with algebra. It's that sort of, if this means that, then this happens. It's sort of that sort of applying logic and powers of deduction, those sorts of things. So we're going to come back to this particular puzzle again later on in the lesson, but I thought let's just have a crack at it. What do you think? So this is an interactive slide. You can just have a little bit of a nut out, see what you think that final line of working would be. You don't have to use algebra again. You might just use deduction and numbers, and then throw in some answers on the screen. So we'll just sit here for a while while people have a little play with it. I'm just going to get my pen and paper out. See, we're in a digital world and I still love my book. Still love it. I feel like I think better when I've got a pen in my hand. Maybe I'm just old school. So I suppose if you're pretty stuck, the first place to start would be that first line. So I know some people are throwing in their responses already. I'm just going to do a holding step in case people are a bit stuck. One place to think about this would be this first line here. So if we've got 1, 2, 3 chickens, and each of the, or I don't know, that could be a rooster. Let's call them chickens. And each of those chickens, 3 of them, adds up to 60. Then basically we have 3 of those chickens equals 60. That's a very bad chicken, but you get the idea. So how much would 1 chicken be worth? So then hopefully we can deduce that 1 chicken, I'm not going to try another one, maybe 1 chicken is equal to 20. So maybe that would be your first starting point. See how the answers are going. Getting a few answers in. Yeah, don't feel rushed. We've got another, well, spend another little minute here or so. If you haven't been able to get the pair deck going, that's okay. You can throw your answer into the chat and Miss J will be able to see it. But our preference would definitely be for you to enter it into the pair deck. So some people still going. I might do the next line. So now we know that this is 20, this little chicken. Ooh, it's white, that won't work on there, will it? So we know that the chicken is 20. And each basket of eggs here Now you could do this a couple ways. Now that's the thing about these puzzles. It's not meant to be a trick problem. It's all about how you've interpreted it and how you solve it. So I'm not going to say that there's a right or a wrong answer. I'm going to say how have you solved it and what do you get at the end there. So here you could interpret this as a basket of eggs, or you could interpret it as there are 3 eggs in each basket. It's entirely up to you. Okay, let's have a little bit of a look. So get some answers on the screen. So, oh, I've got annotations. I'll clear those off. There we go. So there's a bit of a range of answers there. And again, right or wrong, it doesn't matter. It's just about how you've interpreted that answer. So if you actually, Miss J, if you could just, oh, they can talk to us. For those people who have got answers down around here, the 20s and 30s, throw into the chat to Miss J and I how you interpreted that. Just sort of throw in what you did to get that, something very quickly. And those who did that top end, throw in the same, throw into the chat how you got that, because I'm absolutely saying no right or wrong answer. The important bit here is how you interpret the question. That's what makes these memes popular, is because there's multiple interpretations, and it makes rooms for discussion. It really brings the people talking about these things to the forefront. Those. Yeah, there's some good answers coming through there. Fantastic. So certainly most people seem to have worked their way down the puzzle, which is pretty common here. You'd start with the chicken, you'd use the chicken in the next line to then work out what the basket of 3 eggs is. You'd use the basket of eggs in the next line to work out what a bunch of bananas is. And then you'd use those 2 pieces of information to sort of get to that last line. What's really important to note here is, you know, they try and trick you with these things on the internet. So here we've got some things to keep a lookout for. Here we've got a basket of eggs, and then all of a sudden there's 4 eggs in there, whereas before there was 3. But if you interpret it as a basket of eggs, fine. The pictorial representation may not be that important. Here we have 1, 2, 3, 4, 5, 6 bananas. Down here we have 4 bananas. Again, if you've interpreted it as a bunch of bananas, it's a bunch of bananas. If you've interpreted it as a single banana, then you'd need to use that down here. And then the last thing they did is all of a sudden switched in a multiplication sign. So, and then that always brings in that age-old problem. Do you read from left to right? Do we do the multiplication first? So the general consensus in mathematics would be to do, order of operations would be the multiplication first. So yeah. Just some key things there. So it doesn't really matter, you know, the details of the picture. What I wanted you to experience there was that sort of method of deduction in your brain about, oh, if this means this, I can use that information somewhere else. And in essence, that's really what algebraic thinking is. It's using representations for a value. It's using those representations in a different sort of statement, or a, you know, or an expression, or those sorts of things. So fantastic. Okay, well, I better clear those off. Okay, thanks everybody. So let's talk about adding and subtracting. So to add and subtract algebraic terms, the real key thing, overarching, all of it is like terms. We can only add or subtract like terms. So what are like terms? Well, basically, a like term is anything that has the same combination of letters or variables or pronumerals. Different states call them different things. Sometimes a variable is only used if you're going to use it in a varying context. Some states don't use the word pronumeral at all, but other states like it because it means it's not a variable. But key thing is here is that we have some sort of representation. In this first example, we have the letter A. So like terms to A could be, well, I could have 2A. Or I might have 6A, or I might just have half of an A, or I might have 3A over 7. These are all like terms with A because I have the same combinations of letters. In each case, I just have the one letter A. Okay, so like terms to 2AB. Well, now the combination of letters I have is AB. So everything that is like to 2AB has to have that same combination of letters. So maybe I just have minus AB. I could just have one of the ABs. Again, I could have some fraction, AB over 7. I could have 2,356 AB. So again, the common linking factor there is that they all have that same combination of letters. That's what's important. They are all like terms. The number out the front is what doesn't matter. So here I just have a -1. Here I have just a 1. Here I have the 1/7. Here I have 2,356. That's the bit that can vary. That doesn't matter. That's just how many of them you have. And this AB as a group, that's what's important for the like terms. So just one more example. This next example uses powers. So here, the combination of letters is actually the A squared. It's because the A squared, remember when we did A indices, was A times A. So it's like having two lots of A's side by side. So it's very similar to this AB, except for it's two A's. So we've got the A squared. So all like terms to A squared could be something like 2A squared, minus 1A squared, 10A squared, doesn't matter as long as I have A squareds and nothing else. Okay, so I don't want to confuse the screen now with things that are not like terms. Let's assume now that we've got a bit of a feeling for like terms have to have that same combination of letters. That's what's really, really important there. That's what I say there. Like terms have exactly the same combinations of, and you might use any of those words, pronumerals, variables, or letters. At this stage, we're not going to be finicky about their definitions, but you just need to know they have the same combinations of them. So the A is not a like term with the AB or with the A squared. Okay, remove my annotations. So your turn, so on Pear Deck. So I want you now to list me a whole heap of like terms, anything that you can think of that's a like term with the combination A squared B. So you can just go in now into your Pear Deck. You can just write 1 or 2, but we're going to leave the screen up for about a minute. I've started timing now. So get as many like terms with A squared B as you can think of. See if you can be creative. Try and use different types of numbers. We've covered lots of different types of numbers so far this year. Maybe try and throw in an example with a fraction. Try different signs. Have some that are positive, some that are negative. Yeah, so I've got a couple of responses going in. So if you've just joined, this is a good time just to refresh. You need to be in joinpd.com. There's a code in the top right-hand corner, how you can get into our Pear Deck to answer these interactive questions. So we're writing as many like terms as you can. We've got 5 seconds left. So see if you can get a few more in. Get a few more in. Okay, I'm going to just flick over to some of the answers now. Here we go. So A squared B, fantastic. Yep, fantastic. Here we have 1,007,648, A squared B, perfect, well done. 4A squared B, 8A squared B, A squared B over 823, fantastic. Yep, doing well. Minus 2B A squared, that is a fantastic answer. See how it doesn't look like A squared B, but it still means exactly the same thing. So in this case, that's exactly the same combination and it would be a like term. So that's something to watch out for, fantastic. A squared B. This one doesn't have a squared in it, so that one would need to be changed. A squared b on 12. I'm assuming these are squares, just because of the notation would be different. This one would need to have a squared in it. A squared b, yeah, fantastic. Oh, now someone wants me to read that out. I'm not going to read that out. Very large number, a squared b. Maybe that's the number of, don't know, electrons in the universe. It's a huge number. Okay, fantastic, everybody. Okay, we've got really getting the idea here, so I'm just going to close that. So on we go. Okay, so let's look at adding and subtracting with like terms. I'll jump to our book now. And we're going to do a few questions here. So we want to do some questions around adding and subtracting like terms. So I'll just do a few on the screen here. Do that. Okay, so let's going to look at some simplifying expressions using addition and subtraction. So the way that I suggest we approach these things is to look first for your common letters. Look for your like terms. So in this case, there's an X. Hold on one second. There, in this case, there's an X, and then there's some numbers. So we can combine all of the X's together and then all of the digits together. So in this case, we have just the X. There's no other X's to combine. And then the digits that we have is 9 plus 7, and we can do that calculation. That's part of the simplifying. And 9 plus 7 would be like 10 plus 7 less 1, so that's 16. Okay. So in the next case, we have two like terms. We have 9 of the X's, and then we have 4 more of the X's. So if you want to be able to visualize what this is asking, it's saying that I have, I'm just going to do X's this way, it's a bit easier on the screen. 9 of them, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I add 4 more to that. 1, 2, 3, 4. And you can see how that means we can then add them all together. And as a group, then we have 13 of the X's. So we've got 9 of them plus 4 more gave us 13 in total. Okay, subtraction works in much the same way. If you need to be able to visualize the 12p minus 9p, you would have 12 of the p's written out. 1, 2, 3, 4, 6, 10, 11, 12. And then we subtract 9 of them. Please don't consider this as algebra. It's just a group of p's. So we've got 12 of them minus 9 of them, which would leave us, of course, with just 3 of those p's. So identify your like terms and then work out how many you've got. 12 of these p's minus 9 of these p's. Okay, here the like terms are u squareds. So we've got 2 of them and we add 9 more. So altogether we have 11 of those u squareds, 11 of the u squareds. Next case, we have 4 of the m's and we take away 4 of the m's. And whenever you take away all of what you started with, you end up with 0. The last one on this particular page, we have 8 of the p's and we subtract 7 of them, and you're just left with 1 p. Now, mathematical convention says if we don't have any more than 1, we just write the letter. So in this case, they are the same thing. 1p means just p. You don't need to write the 1. In some places, you might lose a mark for doing that because it's not fully simplified, but mathematically, it actually means the same thing. It's not a different number. They have the same value. Okay. Let's just do a couple of these more complicated ones down here, and then we'll move on to the next section. So, firstly, identify our like terms. So we've got a P, and I scan through the others. I've got a Q, a number, there's another P. Okay, so I'll do the P's first, just because I happen to have found them all. I have 10 of them, and I minus 3 of them. That will leave me with 7. Okay, then I move on to I'll just change colour. The next letter, which I have, is Q. Here I have minus 7Q plus 7Q. So that means I'm subtracting the same amount as I have. So they'll have 0q there. So I could write this in as 0q, and then we'll simplify that next step one step further. And the last step is all of the actual just numbers themselves. So we've got 10, and I subtract 3. So 10 minus 3 is 7. So obviously there's a fair bit in here about integers and negatives. So if those sorts of things trick you up with the letters, then go back and do some more practice with just working with the negatives with the whole numbers that we did in chapter 1. You'll have a textbook that'll have some work on integers. So make sure you've got some confidence in integers, confidence in being able to add and subtract, whether that's whole numbers or in fractions, because that will really help. You don't want to get those smaller things as blockers for you to be able to engage with the algebra. Okay, well, just one last step to simplify here. So we have 7p plus 0q. So our mathematical conventions, which is just, you know, our standards about how our mathematicians agree we should write stuff down. Like a mathematical convention is much the same as how in English we need to have a capital letter and a full stop in sentences, where you put your commas or your apostrophes. So when we talk about mathematical conventions, think about it as that sort of grammar aspect. So we don't write the 0q because we actually don't have them. So mathematically, we find that non-useful information, so we wouldn't write that out. So our final answer for this one would be 7p. Oopsie, sorry about that. 7p plus 7. That's how we would write that out. Okay, let's just do one more with the squares in it. Okay, so we're going to identify our like terms. We're going to do this question here. We have PQ. This is a P squared Q, so that's actually different because this would, you remember, would be P times Q. So that's different to just 1P times Q. So I'm looking for other things that are the same as PQ. Here we have a QP. That is the same thing because multiplication is what we call commutative. That means, you know, if we look at numbers, 3 times 4 is the same as 4 times 3. Same is true for letters. P times Q will be the same as Q times 3 because you've got to remember Q times P. You've got to remember that these letters could stand for actual numbers, and if numbers are commutative, then so are the letters. So in this case, PQ is a like term with QP. So I'm going to do that one first. I have 10 of them, and I'm subtracting 8. So 10 of them minus 8 will leave 2 of them, and I'm going to write it as PQ. Because another one of our mathematical conventions, just like not writing the 0q, is that we generally write them in alphabetical order. Okay, then other like terms, what else do we have there? We have P squared Q here and a P squared Q here. So they are like terms. I have plus 4 of them, and so altogether I'm going to have 11 of those P squared Qs. And that's all. Okay, so that's basically adding and subtracting like terms. So the key things you need to know are what's a like term. We've talked a little bit about that today. You need to be able to work with integers. So you need to be able to understand your negatives and be able to add and subtract those. And the other key thing is recognizing where the powers are. So P squared Q is different to PQ, but QP is the same as PQ because of that commutative property.
Miss G, would you mind doing that 11p squared q again, because your sound went a bit garbly?
Sure. This one here?
Yes.
Yeah, okay, let's do that one again. So we're going to look for like terms. We've got PQ, and we're going to look for other PQs. We have a QP. Well, in fact, they are the same because multiplication is commutative. So we know that in numbers, 3 times 4 is the same as 4 times 3. And that actually equates to the same thing. So PQ is also commutative because if they were the same, if they were to take the values of letters and we know of numbers and we know that numbers are commutative, then the letters are commutative too. So the order of those letters is less important than making sure that all of the same letters are present. So we have 10 of them minus 8 of them will be 2 of those PQs. Now, another mathematical convention is to make sure that we write the letters in alphabetical order. Now, they have the same value, so mathematically they are equivalent in terms of the value, PQ and QP, but our standard is that we would write them alphabetically. The other like term in this expression is P squared Q, and we have 2 of those there. We've got P squared Q, we've got 4 of them, and we're going to add 7 more of them. So 4 plus 7 is 11, so we've got 11 P squared Q all together. Okay,
Beautiful. Thank you.
So we've got an example on our next slide here. For you guys to have a go. So simplifying algebraic expressions that use addition and subtraction. So this is one for you to do. Draw your working out on the slide and put your final answer in the yellow box. I'd like to see your workings out. I'd like to see how you're grouping them together and then how you simplify them. You can just draw on the screen. And what we're looking for here are those key skills that we've just discussed. So the first one is identify your like terms. The second one is that you need to be able to deal with integers like negative numbers and be able to add and subtract with those. And we talked about being comfortable with addition and subtraction of integers first before trying to do them with algebra. If you need more practice there, in Mathspace, you'd go back to chapter 1. The other thing you want to be able to do is recognise some of our mathematical conventions. So that's things like how to handle 1p, how to handle 0, lots of something, and that we normally write things in alphabetical order. So there's a few people going in. Maybe instead of writing words, you could have a go at the question there, or you've got an answer in, I suppose. Okay, let's have a look at some of these responses coming up. So Red Panda, nice work, except for you've got, oh, you're just doing the first part. Oh, I see, fantastic. Yeah, you're on the right track. Well done. Squirrel, good work. Squirrel, you need a Y in there. Nice working out there, sheep. Yep. Some people have just put their answers in, that's fine. So we've got, yep, correct answer there for deer and kiwi. Goat's still working, that's good. Okay, I'm going to do a little bit of working out on the screen. Most people are getting some submissions in, which is good. So I'm going to start off the problem, and then you're going to be able to correct yours if you need to. So I'm going to start with the x's. I have minus 2x minus 10x. I'm just going to write them together. And then the y's, I have plus 2y minus 6y. So I've written the same question, but I've just grouped my letters together. Now I'm going to be able to do the x's and the y's. So I've got minus 2 of them, and I take away 10 more. So altogether I will be down at minus 12x. So a lot of people had the minus 12x, that's great. And then the y's, we've got plus 2y minus 6y. So that'll leave me with minus 4y. So you'll see that we had two lots of negatives. Minus 2 minus 10 was minus 12. And 2 minus 6 was minus 4. Okay. So I think most people got that. That's fantastic. Thanks, everybody. Okay, going to do multiplying and dividing in two separate pieces. Just talk about them and then we'll go and do some questions. So multiplying. Now, multiplying term uses our knowledge of, we need to know how to multiply numbers. We also need to understand what indices are. So remember how we spoke about back in, I think it was week 1, we talked about indices and, you know, something like how p times p, we write as p squared. But then if we had p squared and we times it by another p, then altogether we would have p cubed. So it's just an understanding that each of these little powers represents one of these p's being multiplied together. So in this case, we have 1, 2 times another one, gives us 3 altogether. So we don't do a lot of, in year 8, we won't do a lot of indice work, but just recognizing that p squared is a very different thing to just 1p is really important. They're not like terms, they're different. They'll have a different value. So make sure you remember that piece. So my tips for multiplying are, this is how I sort of always approach it. Do your numbers first, then identify all the letters you have and what powers they are. And the standard again is to write them in alphabetical order. So remember when I talked about how numbers are commutative, so something like 3 times 4 is the same as 4 times 3. Well, that is exactly the same with algebra. Any two letters multiplied together, you can reverse the order and the value is the same. So in this case, PQ would be the same as QP, but we want to make sure that we write the order in the correct way. Mathematically, we would normally want to write them in alphabetical, but the value that you have is the same, so that's fine. So let's just have a quick look at some examples. Clear that screen. So you get a bit of a feel for what we're talking about with multiplying and dividing. Typically people seem to find the multiplying a little easier than the adding and subtracting, although then they start getting the two different ways that you handle them a bit wrong and they can get confused. So let's have a look at some simple examples and we'll follow the rules that I've just been talking about. My general approach is not a rule, you don't have to solve them this way, but my general approach is always numbers first. So we've got 6 times 10 is 60. And here I have the letter N. So I'm just going to keep going with that approach. I have 9 times 8 is 72. And look for the letters, I have M times N. And remember, I just spoke about how one of our conventions is to write them without the multiplication sign. So they're the same thing. Down here we have 9 times 6 is 54. And then look for the letters I have. So I've got 1R and 1S. Okay, so multiplying is basically like that. Numbers first, find the letters you have, and then write them generally in alphabetical order. So, oh, that's a tricky one. I gave you a hard one, didn't I? There's a multiplication one, it's got powers. If you don't like to look at the powers and you want to make the question a bit easier for yourself, then I'm going to give you an option. You can do the question that's there, or, which is a pretty chunky one, if you can do that, you've nailed multiplying for year 8. If you want an easier one to begin with, then let's just do this question instead. If you want an easier one, then I would just do minus 10R times 6S. That would be an easier one to begin with. But if you want to throw yourself in the deep end, then try that one with the powers. So just draw anywhere on the slide, set out your working. Remember, my general feeling is numbers first, and then write all the letters down. Yes, you guys are doing well. Well done. Great starfish. That's excellent, horse. Yep, you're on the right track there, red panda. That's great. Yep, nice work, goat. Doing well. Okay, I'm going to do the easy one first. So I'm going to do our easy version here. Here we have numbers first. So minus 10 times 6 is minus 60. And the letters that I have is just an RS. If I do this harder one that we started with on the slide, it was minus 10 R to the 8th times 6 S to the 7th. So numbers first, negative 10 times 6 is negative 60. And then the letters, I have an R to the 8, that's just one term. And I have an S to the 7th, that's the second term. So whichever question you did there, you want to get one of those two answers. Okay. Clear them. Turn that off. Okay. Dividing. So it's basically the same sort of thing. What I've got here is my tips for dividing are numbers first. If you can't divide fully, then just simplify that fraction. Then look at all the letters you have and see if you have anything that cancels out. So this uses the idea, and this is really important. This is just a numeric idea that we relate to algebra. Anything divided by itself is 1. So 3 divided by 3 is 1. 1200 divided by 1200 is 1. So anything that divided by itself is 1, and the same applies to algebra. P divided by P is 1, because you've got to remember that normally these P stand for a value, like a number, like 3. And then if we did do that, and you had 3 divided by 3, you would have the value 1. So that's really important. So what we want to make sure you know how to do is know your division, know how to handle fractions, watch out for your negative signs, and we did talk about negatives and multiplying and dividing in the first week, so you could go back and watch that video if you get tricked up with negatives. What we're going to do is have a quick look at a few of them and get you to do one in a second. So my turn first and then your turn next. So we've got some divisions down here. Lots of multiplying practice. Here we have some division. So division can be one of two things. It can be written as a fraction, or it can be written using a division sign. They mean the same thing. So in this case, we have 2x divided by 2. Remember, numbers first. 2 divided by 2 is just 1. So this just leaves us with 1x. In this next case, we're going to do this one here now. 15 divided by 5 is 3. What letters do I have left? Just the V. You'll notice in both these cases, the letters are on the top of the fraction. That matters, because when we get a bit further down and they're not, we might have to leave the letter on the bottom of the fraction. We're going to do this next question. Numbers first. We've got 5 over 20. So that's a fraction. 5 over 20. I said one of the key skills you need to be able to have here is how to simplify fractions. So 5/20ths is of course the same as 1/4, because we can divide both top and bottom by 5. So we'll end up with 1/4 of the m. We can write it like this. We could write it like this. They are the same. representation of the same value. Okay, so 1/4 m is the same as m divided by 4. The division sign means basically it's a fraction. So some people prefer to see it as a fraction because then they can see what they need to simplify. So this would be the same as 5m over 40. The divided by symbol here is where the fraction goes. So Miss G's tips for multiplying and dividing was numbers first. So here we have 5/40. Can I simplify 5/40? Well, yes, I can. That is the same as 1/8. So this is the same as 1/8 m, or just m on 8. Keep pumping my button. Okay. Let's do a slightly trickier one from down the bottom. Here we go. Let's look here. I'm sure a lot of you are up to this level already because you've been throwing your answers in really quickly. So here we're going to look at this question. 63 PQ divided by 9P. Okay, so numbers first. 63 divided by 9 is 7. I don't need to simplify the fraction. That divides fully. That leaves me with the PQ divided by P. Well, remember that anything divided by itself is 1. So there's a P here and a P here, so that's just 1. We can only do, this is what we call cancelling out. We can only do that for exactly the same term. If you had P squared and P, we could simplify that and we would have to use some indice work to solve this sort of thing. But that generally you won't do until year 9. So we just need to focus for the moment on making sure that what we are cancelling out are like terms. And in this case, we have a P and a P. If we had P squared and P squared, like terms, we can cancel them out. Anything divided by itself is 1. So we're going to end up with no P's left here, and then we're just left with a Q. So that's how you would do something like this first one. I'm going to do this one here and then give you a turn at dividing. So numbers first, 12 divided by 15. I can't do that evenly, so now I have to think about it as a fraction. How can I simplify this fraction, 12/15? Well, I've got to look for common factors. I see a common factor of 3. So this will simplify to 4/5. So remember, it's really important that when we're working in our algebra land, that you are first proficient in numbers. Make sure you're good at your multiplication facts, you've got good division, you're fairly good with your arithmetic, and you can simplify fractions. That's pretty important. So we've got here 4/5 is our numbers. And now looking at our letters, we've got M, M, and an N. Again, cancel out where we can. So we've got an M and an M. Anything divided by itself is 1. So they'll cancel out and leave it with just one N. That N is really important to remember that it's on the top of the fraction, the numerator. So we want to make sure you leave that N on the numerator of the fraction. I think I'll do this next one here because it is a bit different and it'll give you a different experience. So this is our last one on this page, then I'll give you a turn. So simplify the expression. So numbers first, well, there's only one number, it's a 6. I've got nothing to simplify it with, so I'm going to leave the 6 where it is. My letters, I've got R and an RW on the bottom. So anything divided by itself is 1. So the R can cancel out with the R, that's fine. They are like terms, they'll cancel out nicely. What does that leave me? It just leaves me with the W. And the W is on the bottom. So you're going to make sure you leave the letters where they appear. Is it in the numerator? Is it in the denominator? Because 6 divided by W is very different to the 6W that you could do if you wrote the W in the wrong place. So my Miss G's tips for multiplying and dividing. Numbers first. If you can't divide fully, then simplify where you can, and then identify the letters and work with those. Okay, so I think it's your turn. There we go. Okay, so is it your turn? We've got a minus 24r to the 4th divided by 6r to the 4th. So have a go at that one. Just gonna check on some answers. How are we going? So Miss G's tips, remember, were think about numbers first and then look at what you can simplify with regards to the letters. I'm going to make a start. So maybe flick back to my screen if you're a bit stuck or you want to check if you're on the right track. I'm going to write this first as a fraction. That'll help me identify where and what I might be able to cancel out. So 24 r to the 4th. The divided by means where the fraction line is. 6 r to the 4th. Okay, so Miss G's tips are numbers first. So I have negative 24 divided by 6. So negative 24 divided by 6. So when we did negatives, we talked about numbers first, think about the signs. So 24 divided by 6 is 4. Different signs means the answer stays negative. So I've got negative 4. I see lots of people have that 4, which is fantastic. Lots of people have the 4. That's awesome. And now we need to look at the variable. So we've got an r to the 4th and an r to the 4th. So remember that 4, this little power 4 belongs with the r. It's saying I have r multiplied by itself 4 times. It's like seeing this r as a term, 4 of them together. These all mean the same thing, r to the 4th. So if I have an r to the 4th on the top and an r to the 4th on the bottom, they are like terms and I can cancel them out fully. So they would cancel out completely and I will end up with no letters left. The letters are gone. So the answer to this question is just negative 4. There are a couple of people here who have some indices still left over. So I think this point here is really important for you, that the 4 is not a number on its own. We don't just cancel out. We can't just do this. This is what I've seen a few people do. We can't just do that. It's the whole term that we're cancelling out, the r to the 4th and the r to the 4th. The 4 actually means that there's lots of letters in there. So if you're getting a bit tricked up with the powers, that's okay. It's the hardest part of our algebra that you'll do in year 8. So it's a pretty hard question. If you're getting tricked up with that, go back and look at indices. We've got some practice work in chapter 1, but your textbook will have indices somewhere in it too. Okay. Going to move on to the next slide there. There's some good questions we're going to get to in a minute in the Q&A, so that's fine. Just going to clear those off. Okay, so broadly simplifying, we'll use all of what we've just talked about. So when you're simplifying more complex expressions, it's still the same thing. What are my like terms? What can I add together? What is the order? Just like when you were doing, if you were going to do a numeric simplification that had something like 3 plus 2 times 7. We know to do the multiplication first. 2 times 7 is 14, and then still add the 3, so we would get the answer of 17. The same ideas are really important. If we just start having letters in amongst all of this, we still need to do them in the same order. The multiplication and the division, then the addition and subtraction, and then later on when we get to brackets, we'll include those too. So we're combining now a lot of ideas that we've got about numbers together and throwing all those concepts in to our new work with algebra, but all those same laws apply. So just do 1 or 2. We might run a little bit over, and I think that will be okay because this is a pretty important section. Okay. So let's just do 1 or 2 of these, and then I'll give you one to do. So remember my tips for simplifying, to think about them in terms of firstly identify, the order of the operations that you're going to do. Where are my multiplications and divisions? Where are my brackets? Where are my additions and subtractions? And then you apply the layer of I can only add and subtract like terms. Or when I multiply and divide, I need to simplify the numbers first. The most important thing is to do this small steps at a time. The more you try and do in each step, the more likely it is for a student to make a mistake. So especially when you're learning, try and do very small steps each time. Try not to do too much at once. So let's do, okay, let's do this one here first. We'll start at the very beginning. 2t plus 4 times 8t. So multiplication and division first, 4 times 8t. So I'm just going to, just use my hand. I'll cover up that first piece and just think about the multiplication. So my first step is numbers first. 4 8s are 32. I have the letter T, and I still have this plus 2t at the beginning. That's my first step, is just that multiplication piece. Now I have an addition and subtraction, and I've got to make sure I'm only adding and subtracting like terms, and I can see here that they are. They're both just t's. So when I add and subtract those, I have 2 plus 32 more, gives me 34 in total. Okay, let's do this one here. 12u divided by 3 minus 2u. So the first thing I'm going to do is write it as a fraction. 12u divided by 3 minus 2u. Okay, I'm going to do this simplification first, this one here. So numbers first, 12 divided by 3. Well, that gives me 12 divided by 3 is 4. What letters do I have? I can't do any simplifying. There's no cancelling, so I just have a 4u. I still have this minus 2u. So I'm going to just bring that onto my next line. And then I have 4u minus 2u, which is 2u. Okay. These can get pretty complicated. You can have lots of steps involved in these. You'll see that there are some more complicated ones further down. What I'm going to do is we're going to jump to the you try one. I'm going to check out the Q&A and come back and answer some of your questions. So here's a you try. You've got two options here. I've already set up an easier one and a harder one. They just look a bit different. Pick one that you think you want to try. And just do one of those questions. I don't mind which one. So we've got one that's set up as a fraction. There's multiplication, division and addition. And this one over here has two groups of multiplication and an addition. So have a go at one of those. Either one, won't matter. You're well done, Al. Doing well. Well done, Kiwi. Yep, well done, Donkey. Yeah, I'll just do these questions and then we'll answer the Q&A. So let's do the one on the left first. So we have 58r plus 5r on the top of the fraction. If I simplify that, I'm going to have 63 r's on the top. The reason I'm doing this piece first is because even though we've got a multiplication and a division, that is all one term on the top of a fraction. So I kind of need to know what that is before I can do anything with it. And then I have my fraction, and on the bottom I have 3 times 7r. So numbers first, 3 times 7 is 21. What letters do I have? I have the letter R. So that's my first step for this one. Most people who did this, and that was basically their first step as well, which is fantastic. Simplify the numerator and the denominator, see what you've got left. Now I've got this, it's basically a division. I'm going to do numbers first, 63 over 21. That looks like I can divide evenly. So that's going to be the number 3. There are 3, so 3 21s are 63. And what I have here is R divided by R. Well, anything divided by itself is 1. So that ends up being 3 because that R will cancel out. Anything divided by itself is 1. And that's true for numbers as it is true in letters. Okay, the one on the right hand side, if you chose to do that, I've got 2 lots of multiplications. I'm going to work out each of these and then add them together if I can. I can only add if they're like terms. So multiplying numbers first, 3 times 8 is 24, and I have an A in that term. My second term is 6 times 2, which is 12 A's. And now I can see that they are like terms. They're both the letter A. So when I add them together, I get 24 plus 12 is 36 of those A's. So that's where we're heading, and I see lots of good working out too. So thank you for doing all your working out. It's really great to see. Okay. So one thing I'd like to clear up. Something that's come out of the Q&A. First thing is, let's look at some different cases. Something like 10A times 3A. Let's also look at 10A divided by 3A and 10A plus 3A. Just to highlight the differences here between these operations, okay? So in the addition and subtraction, we can only add and subtract if they're like terms. So if they're the same, then we can just count up basically how many we have altogether. I had 10 of them. I added 3 more. I have 13 altogether. Sorry if that's a bit hard to read. With the multiplication and division, we do that in 2 different ways. Firstly, the 10A divided by the 3A, we look at the division. We do numbers first. Can I simplify 10/3? No, I can't. So that just stays as it is. There's no common factors and I can't divide it fully. But anything divided by itself is 1. Same is true for numbers as it is for letters. So this one just becomes 10/3. And with the multiplication, we do numbers first. So 10 times 3 is 30. And then we look at our letters. We have an A times an A. It's not just 10, it's not just 30A, because we have A times A. And knowing our idea about indices, this becomes 30A squared, because we have 2 of them, AA or A squared. That's slightly different to if we had 10A times 3B. In this case, the letters are different. So we would have 10 times 3 is 30. And we have the letters A and B. We write them down separately. So we have A squared, A times A, or we have AB, AB. We write them together. So try and think about these 4 cases. Keep them in mind. See how we treated them all differently. They each have their own specific way that we need to handle them. And it would be the same as if we were handling them and there were no A's there at all. It would be the same with the actual numbers. How we handle multiplication or division or addition or subtraction. But this is an important one to note. When we're multiplying 2 letters the same, we end up with this idea of indices. Now, for a lot of people in their states, you won't do this sort of multiplication in year 8 with the indices. States like New South Wales probably will, but if you're in other states, you're more likely to be doing this sort of work in year 8, and the other one with the powers will come next year. So because we're doing one class for all of Australia and all the states are slightly different, make sure you're pretty clear with your teacher if you need to know this multiplication with the indices, because that's not in our current year 8 book, because this is for the Australian curriculum, which would be states like Victoria or South Australia, WA. But if you're in New South Wales particularly, you'd need to check with your teacher. Okay, so we've gone a little bit over time, but I'm okay with that actually. Miss J, was there anything else in the Q&A that I needed to have a look at?
We did have one other question, but you may have answered it when you were doing one of the problems where you talked about the commutative property. The person who asked that question, I think everybody can see that. Liz, you want to pop in the chat if you got that question answered?
So what we'll do then is I'll just leave you with a little bit of homework back to that chicken puzzle. Not interested in solving it more fully this time, or getting caught up in whether it's a trick or any of those sorts of things. Just interested in making that connection between representations and writing things using letters as a representation for the problem. So maybe just before next week, see if you can write out each of these lines using letters instead of pictures and make them lines of algebra. So for my first one, I might like to call each chicken. I might say a chicken is the letter, let's just go with C because it seems obvious. Then in this case, I would have C plus C plus C. And then I could write C plus C plus C as 3C. So all I want you to do, you don't need to do anything more. We're not going to solve them. I'm just interested in getting you some practice at being able to write expressions and interpret them using our algebraic notation. So that's our homework for next week. So next week we're going to be continuing with algebra. So that's great because it means you can come back next week with any questions from any of the stuff that we've done today. Adding, subtracting, multiplying, dividing, or simplifying expressions, okay? So if you come with questions, you'll just be able to jump on next week, throw them in the Q&A, and we'll be able to jump into some of those, tidying up our loose ends. But otherwise, that's it for this week. So next week, we're on to expanding and factorizing. So thanks everybody for coming. Hope you have a great weekend, great week next week. And I really would like to see you again next Thursday.
Thanks for coming, everybody.